In this question, we've got the graph and we want to write the function. It says in terms of sine x, so that means you need to find all of those values, a, b, c, and d, that would go in there. So we're going to sort of think backwards with our DABC and say, what did each of those things stand for? And can we see that just by looking at the graph? So what was D? That was the first thing that we graphed. That's our center line. Can you tell where the center line is on here? -1? Does that look like right in the middle? No, not quite. Whoa. Did it connect all of them? Oh, yes. 1? Does that look like it's right in the middle? How do we know? Well, so let's say we think it's equal to 1. I'll put it in red because that was our center line. A couple of ways we could know our center line. We can now measure the distance from our center line to the top and to the bottom. If it's the same, it's in the middle. If it's different, you know it's not in the middle. So now, if we go 1 up to 6, that distance is 5. If we go 1 down to -4, that distance is 5. So that's good. Another way that you could find the center line. Would you know how we said sometimes that different names for our center line? Center line, sinusoidal axis, and sometimes I said average. Now, if we think of average, how do you find an average? If you got 10% on your first unit test and you got 20% on your second unit test, what's your mark in the course? 15%. How did you do that? You added them up and you divide by how many you have, right? That's how you find an average. Well, if we wanted to find an average, we could say, I know the minimum's at -4. I know the maximum is at 6. If I add 6 and -4 up together, I'm going to get 2. Divided by 2 because I have 2 of those. And I get 1, so my average is 1. So our D value is 1. What's our A value going to be? What did A stand for? Amplitude. We used our amplitude to find our maximum and to find our minimum. In this case, it's going to be 5. What did we use our B value on our graph for? The period. What is the period? So we can just look at the graph here and we can say what the period is. 2 pi over 3. So one way you can do that is you can take a point like this minimum and go to that value and figure out how far is that. As far as counting it, if we counted just spaces, we go 1, 2, 3, 4, 5, 6, 7, 8 spaces. What is each space equal to? How much is one of these spaces? Pi over 12. So if we did 8, if we just counted spaces, we could do 8 pi over 12 because there's 8 of those spaces, which reduces to 2 pi over 3. Now that's a way that you could do it if you were just counting. Probably some of you just looked at this length and said, well, if I move 1 over from that, that goes from 0 to 2 pi over 3, and you might have just used your scale to figure that out. Yes?
I did, like, you know, when you have to divide by 4, like the DABC, it's kind of.
Oh, you looked at how it was divided by 4 sections, and it was divided up to 2 pi over 3? Good. Now, if the period is 2 pi over 3, does that make my B value 2 pi over 3?
No, you have to multiply 2.
Okay. So a couple of things. Remember, we've got a couple of formulas. We had our formula that our period was equal to 2 pi over the B value. And rearranging that formula, we have our B value is 2 pi over our period. Now, there's a couple of ways that you could figure this out. One, if you wanted to use the B value formula, right, you could just plug in your period there. And you'd have 2 pi divided by 2 pi over 3. How do we do this mathematically? Well, when you're dividing by a fraction, you multiply by the reciprocal. So your B value would equal 2 pi over 1 multiplied by the reciprocal, 3 over 2 pi. These nicely simplify out, and we find out that our b value would be 3. The other way that you might see this is just in the format that this is in. Your period is 2 pi over 3. And what's your formula for period? Period is 2 pi over b. Oh, and you could just see it directly that it would have to be 3. Because if your period's 2 pi over b and your period's 2 pi over 3, it's just a coincidence that b rhymes with 3, and that's your answer. So the D, the A, and the B are going to be the main things you're going to find to start with. Then after that, the C value, this is where you get a bunch of infinite answers. Question? The B value is how much of a compression or a stretch there is. And the period is how long it takes to repeat. So a normal sine graph starts with a period of 2 pi and a B value of 1. And then as you stretch or compress it, then your period changes. Yes. The C is the horizontal shift. And the key to figuring out what the C value is to think about where does sine normally start? Sine starts in the middle going up. So can you find a point on this graph where it's in the middle going up? Here's my middle line. There's a point where it's in the middle going up. Are there any other points where it's in the middle going up? Yeah, there's one over here. Those are two possibilities. There would be others if we kept on going. And this is why earlier I said there could be an infinite amount of right answers. So the way that we write it, and let's just write down some possibilities. Again, we notice that we've marked pi over 12 as one section on here. The first one is 1, 2, 3 pi over 12 to the right. So 3 pi over 12 is one possibility. And you could reduce this because it's equal to pi over 4. What's another possibility? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 pi over 12 to the right. Those are two of our possibilities. So now when we go to write the equation, and often I won't even write things down for C, I will start by writing my equation. Whoa. So I'll go to write my equation. I'll put in my A value, which is 1. You don't have to write the 1, but since it's there, I wrote it. Sine. I'll put in my B value, which is 3. I'll leave a blank for my C value, and then I'll write my D value, which is plus 5. Because the D and the A and the B are going to be the same no matter what, no matter if you use sine or cosine. Can you see if we tried to make a cosine graph on this, it still has the same center line? It still has the same period, and it still has the same amplitude, which I wrote down wrong. I got these in the wrong order. That is why there was. The amplitude is 5, and the center line is 1. There we go. Is that what you noticed? Yes. Okay. So now we've got, that part is going to stay the same. Because if we looked at a cosine graph, it still has an amplitude of 5. The starting value is what could change. So if we used the 3 pi over 12, that's 3 pi over 12 to the right of where the starting value normally is. So we could write that as minus 3 pi over 12 or pi over 4. Another equation for this one. The 5 stays the same, the sine stays the same, the 3 stays the same. The plus 1 stays the same. But if we chose the other starting point, we could have negative or x, there we go. X minus negative 11 pi over 12. It's hard to count on there
Yeah.
because it's going by a weird number. Okay? Now I'm going to ask you to write another one. I'm going to give you all of the information, but this time, instead of a positive sign graph, we're going to make it a negative sign graph. Can you tell me what equation? Looking at the graph, we'll go back up here. Tell me a value that could be in there if we wanted a negative sign graph. First of all, if you're looking for a negative sign graph, where is it going to start? So you can start a maximum, in the middle, or a minimum. It's still going to start in the middle. But what will that negative do? Instead of going up, it's going to be going down. Do we have any points on this graph that are doing that?
Yeah.
There's one right here, right? And there's another one right there. So we could actually choose any one of those values. If I choose this first one on the left, what would my translation be? Pi over 12 to the left. So then I would have plus pi over 12 in there. If I chose the other one, if we go to count that one, if we go by pi over 12s, 1, 2, 3, 4, 5, 6, 7 to the right, minus 7 pi over 12. Now, if you were asked to do this on a test, you just have to provide one of those. You choose whichever one you would like, but this shows you that there are infinite. And if our graph kept on going, we'd find more points that it was in the middle going up. And we'd find more points in the middle going down. I'm getting the 3 pi over 12 and the 11 pi over 12 from these green points right here, because a sign graph starts in the middle on your center line going up. So I look on my graph, where's my center line? Where are the points where it's in the middle going up? And this first one right here is at 3 pi over 12, because each of these marks is 1 pi over 12, so 1 pi over 12, 2 pi over 12, 3 pi over 12. And similarly, if I kept counting, this one over here would be at 11 pi over 12. Yes?
On the test, are we allowed to pick like any single one of those four?
You could pick any one of those four, right? If you really want to cause me grief, you could try to pick one that's about 3 miles to the right, and then I'd have to check if it was actually right. Yeah, better not. And then the negative ones as well. And this question, we notice, said in terms of sign. Can you see that if you did cosine, everything would be identical except for the starting point? So just for fun, up here, 5 cos 3 x bracket bracket plus 1. That would all be the same. The dab part doesn't change, just the c value. Where does cosine start? At a maximum. There's a maximum. When does that happen? 1, 2, 3, 4, 5 pi over 12 to the right. So this means that no matter which of these equations I use, they produce this same graph. That also means that if I pick a value, let's see, an easy value that we can tell from here. Let's use the maximum. If I plug in 5 pi over 12 in for x here, I'm going to get 6. If I plug in 5 pi over 12 in for x in this first sine equation, I'll get 6. Doesn't matter which equation I use, it'll always produce the same graph, and it will produce the same answers. Yes?
So, this for asking, this is a sine graph, right?
It's a sine and a cosine graph. It's called a sinusoidal, and that encompasses both sine graphs and cosine graphs. Because all a cosine graph is a sine graph moved, right? That's what a sine graph would say. And a cosine graph would say, no, all a sine graph is a cosine graph moved. And they fight with each other that way. But who is first? Which graph was first? But they're identical, just translations of each other. Yeah, they're like twins. That's why they fight so much. So, as a result, the D, the A, and the B stay the same. It's just the starting point. No, because it would be both. Okay? What is going to happen on a test is sometimes they'll say write in terms of sine, then they're wanting the equation with sine. Sometimes they'll say write in terms of cos x, then they want your equation with cos. Sometimes they'll say give two equations, one with sine, one with cos. And then you'd have to write them both.
So how many points is this on unit test?
How many are these on a unit test? Sometimes 3 or 4, because you have 3 or 4 things to find. But in the end, there's not much work that you're showing. Often the A and the D values, since they're so easy to see, are half a mark each. The B value, because you have to do a little bit of work with the period, is usually 1 mark. And then the shift is usually 1 mark. Okay, so we are going to practice some of these 4, 5, 6, and 7 right now.